Hello and welcome to this guide to colour correction, which will cover the basics of correcting clips in Premiere Pro. It's worth stating that the principles are general enough to apply to all video editing software packages that have the standard colour correction tools we'll be using, and there are some free editors that do have these tools. It's also worth stating that this guide will get you up and running to a good level, but that colour correction is both an art and a science that can take a good time to master. So first I'm going to correct a couple of clips fairly quickly without going into too much detail so that you can quickly get an idea of what's involved. Next I'll explain at a basic level what a waveform monitor and an RGB parade is, as well as how and why to use them. Finally, I'll revisit the same two clips we started with and show how these tools, along with some fairly standard tricks, can help with correcting your footage so that it looks an awful lot better. So here are my two clips. One is outside, the other inside, or external and internal, as we should say in production. The first one is overexposed and too cold or blue, whereas this second one here is inside and too dark, as well as too warm or red. And this is often the nature of badly captured footage without white balancing cameras properly, where we have outside shots sometimes being too cold and inside shots being too warm. Anyway, here we go with correcting the first one, and if you don't already know, the standard effect we use in Premiere is called Lumetri Color. So I'm going to grab that from my effects panel and drop it on the clip in the timeline before adjusting it. As ever, I want my effects controls visible most of the time so that I can see exactly what's going on with each clip. So within the Lumetri Color effect, I'm just going to use the controls within the basic correction section here, and I'm going to observe what's going on in my waveform monitor, which I'll explain later. So when we use the term color correction, we usually really mean changing three things: the brightness or luminance, as well as color or hue, and also the amount of colour or the saturation, because every pixel has these three basic values: luminance, hue and saturation. The general order of doing things is to adjust the luminance first and then deal with the colour, although after that you may need to again adjust the luminance and then again adjust the colour and go back and forth until things are just right. So I'm going to start with this first clip by bringing the exposure down a bit and then adjusting the colour with the temperature and tint. I can then compare before and after by switching the effect off and on again, and that certainly looks better. And on to our next clip. Again, I'm going to drop the Lumetri Color effect onto it and start with exposure. This is too dark, so I'm going to first increase the exposure a bit and then adjust the colour balance with temperature and tint. There's too much colour altogether going on here, so I'm going to bring down the saturation a bit. Again, I can compare before and after by switching the effect off and on, and it does look a lot better. There is still a horrible yellowy shadow behind our subject, but fixing that is a separate job for another time. So you'll have noticed that I had this waveform visible as I corrected the clips, and you may wonder indeed why we should bother with that at all. Well, the main reason is that you can't trust your eyes alone when correcting things, and one of the reasons for that is that you can't trust the screen you're working on. Unless you use a very expensive and well-calibrated screen in a room with exactly the right lighting conditions, then the brightness and the colours you will see to varying degrees will be inaccurate. This means that even if you correct things to seem perfect on your own screen, they may look very different on other screens somewhere else. Apart from that, everyone's eyes are a little bit different. So we need some way of judging things accurately and reliably, and that's where scopes come in. Scopes is the general term that applies to a number of measuring tools that we use for reliable feedback with our clips. If you don't use scopes, then you can't really judge what you're seeing and doing. Two of the most important ones are the Waveform Monitor and the RGB Parade. So this is where you need to be a little bit patient for a couple of minutes and try to follow my explanations with some quite boring looking blocks of light and dark shades plus some colours. If you can manage that, then we'll soon get back to the real-world footage, and using scopes will then actually become both interesting and useful to you when you work with your own more interesting footage. So let's have a look at the waveform monitor first. This is used for exposure or brightness, or more precisely luminance. So starting with a black screen, we can see that the waveform monitor reports a luminance of 0 across the entire output in the program monitor. If we add a column of pure white on the left of the program monitor, we see that the waveform reports 100% luminance in the corresponding section. If we add a slightly less bright column, we see a slightly lower luminance level reported, and so on with all my columns. Now, if you have a badly set up screen, or your screen isn't very good, or if you're working in a very bright room, or your eyes are slightly different to mine, you may not detect an accurate difference between the luminance levels of some of these columns. So for example, some of you may not see the right level of difference between this very bright column here and the slightly dimmer one next to it. Or you may not see an accurate difference between this dark column here and the even darker one next to it. If your setup isn't very good, they might even look exactly the same. So let's now add a fairly bright block in the middle of the program monitor above a darker column. So along this entire vertical section of the screen where our middle column is, we have a small amount of brighter pixels signified by this thinner line in the waveform monitor, and we also have a larger number of darker pixels in the program monitor signified by this thicker line below in the waveform. Now, back to our first stage of color correction with Lumetri Color, which is the luminance first before we actually deal with the colors next. So I'm going to drop the Lumetri Color effect on the clip, and let's cover the luminance tools in basic correction. First, there's exposure. This is an Adobe control that you won't always find in other editors, and we use it for very quick adjustments. So if I move it up and down, you will see luminance levels change more or less in a fairly natural way that corresponds to our perceptions of overall exposure. More universal and specific parameters are the ones beneath it, which you can think of as anchors to pull or push luminance up or down. So let's start with the extremes. If I adjust the whites, it's like throwing an anchor up here and then pulling the luminance up or down from that point. It will still affect the darker elements of the picture, but not anywhere as much as the very bright bits. So for example, if I had a really bright sky in an image, but the rest of the picture was about okay, I would just push the whites down a bit. At the other end, the blacks parameter is like attaching an anchor down here and affecting the darker sections more than the others. So for example, I can make the darker parts of the picture brighter whilst changing the already brightest bits very little. Now the highlight and the shadows work the same way, but with my anchor more towards the mid-range of luminance. So if I pull down the highlights, it's like throwing an anchor about here and pulling it up or pushing it down. And the same with the shadows, throwing an anchor around here and pulling the luminance up or pushing it down. And again, this affects luminance levels less where they're further away. Also, we have contrast, which instead of being like an anchor is more like a vice in the middle that will push or contract brightness levels from the center. So if I increase contrast, the bright pixels become brighter whilst the darker pixels get even darker. If I reduce contrast, it pulls the bright and dark elements closer to the same level of brightness. Right, now a little bit with color bars and another important scope, the RGB Parade. I'm going to turn on my RGB Parade and for now turn off my waveform. The RGB Parade is in fact just 3 waveforms next to each other, one for just the reds, one for the greens and one for the blues. When we have a black program monitor, the levels of red, green and blue, or RGB, are all at 0, as we can see here. If I introduce a red horizontal block in my program monitor, we can see that the luminance of the red pixels is reported in the red section on the left of the RGB Parade. And the same for green and the same for blue. So we currently have equal levels of red, green and blue. If I now go into the basic correction section of our Lumetri Color and I adjust the temperature, we now see how this changes the balance between reds and blues, leaving the green somewhere in the middle of the two. So the temperature parameter is a balance between warm or red and cold and blue. It's easy to remember which way round it works if you think of increased temperatures getting warmer, that is red, or decreasing the temperature and getting colder, as in blue. The other crucial parameter is tint, which takes the red and blue together and balances them against the green. So when I push the tint up, I'm increasing the red and blue together relative to green, and when I bring the tint down, I'm bringing the red and blue down together relative to the green. Why does any of this matter? Well, more experience will help you realise the many ways this will help, but let's start with one of the most helpful applications. If you can find something that you know is supposed to be white in your footage, then basic correction becomes easier using the RGB Parade. All TV colours are made from these three primary colours, red, green and blue, and white is an equal combination of each. So where there is supposed to be white in your program monitor, the three colours should match up to the same level in your RGB Parade. If we look at this image, then let's say we know that this box on the left is supposed to be white. And while we're at it, let's say that we know that the background is supposed to be grey. But the whole image is, of course, currently wrong. So a good way to fix it is using the RGB Parade. We can see that what should be this white box is represented by these levels of colour in our RGB Parade. So the red level is here, the amount of green is here, and the blue is here. To make it accurately white, I'm going to first balance the red and the blue to bring them to the same level. Now I'm going to change the tint to balance the red and blue with the green. And now the box is white and the whole image is corrected. And we can always check before and after by switching the effect off and on, before and after. Definitely an improvement there. It's worth noting that with this single instance of Lumetri Color, you have to get the luminance right at the start. Look what happens if I now decide to make the whole image brighter by increasing the exposure after I have adjusted the colour balance. The colours go out of line because the changes are related to the original values being fed into the effect. So I can either now readjust the colour levels again by adjusting the temperature and then the tint again, or much easier, I can add a new instance of Lumetri Color. So if I add that and then up the exposure, there we go. Now that the new values are being fed into this new instance of the effect, my colour balance doesn't change. Finally, your life gets a little easier for you, because now that I've finally explained the RGB Parade scope, I'm going to tell you that you don't actually need to use it that much. This is because you can use the RGB version of the Waveform, which combines the monitoring of luminance and colour. In Lumetri scopes, hit the spanner underneath and make sure that you only have the waveform viewable, and make sure that the type of waveform is RGB. Now, a rehash of the same procedure with the addition of two colours we want to look out for in the waveform, and they are purple and white. So if I delete the second instance of Lumetri Color and reset the first one here, I can start from scratch. Now, with our waveform, remember, we have just one whole section that represents the entire program monitor rather than the three separate sections for RG and B. This time, the levels of RG and B appear on the same plane for our white box. We adjust the temperature so that red and blue are balanced, and when they are, we get a purple line because red mixed with blue gives us purple. Then we change the tint to balance that with the green, and we should get as close to a white line as possible. And certainly the box in our image looks white and the rest of it looks well balanced. Now, quickly back to our real-world images and a final quick edit using our RGB waveform. I'm going to reset the Lumetri Color effect on each of the two clips, and then let's start again with the outside shot. First, let's bring down the exposure a bit so that all the colours fit within the range of our RGB waveform. Now for the colour, and notice the white paint in the road. And here's a little trick to make things a little easier. Add the crop effect to your clip and crop out everything apart from the little bit you know that should be white. Now take the zoom box to expand your little selection and blow it up across the whole picture. And now we're set. balance the red and the blue with the temperature control. And there we have a nice purple line in our RGB waveform. Now adjust the tint to balance the purple with the green. And now we have a white line in the waveform. All we need to do now is turn the crop effect off. Now we have a decent picture, and we can check the before and after again by switching our Lumetri Color effect for this clip off and on. Finally, our interview indoors, and let's assume that our background wall is more or less white. Let's first bring up the exposure a bit before the red begins to get squashed. Next, balance the red and blue as best we can with the temperature control. It might help to get the green out of the way temporarily first by adjusting the tint. And as you can see, our purple line isn't really perfect, but we're only doing basic colour correction at this stage here. As a general rule, we should focus on the area most important to us, which is the area around our subject. Now a quick balance of the green with tint. Next, there's too much colour going on all round, so I'm just going to bring down the saturation a little bit. And just for good measure, I'm going to add another instance of Lumetri Color to brighten up what we now have. In fact, I don't really want to brighten up the wall here, so I'm going to add a very rough mask to the second instance of Lumetri Color. And I'll add a huge feather to the mask. And now I can bring up the exposure for just that area inside the mask. Again, I should check the before and the after, and yes, that helps. So there we have a reasonable basic colour and exposure adjustment with a little extra tinkering at the end that I couldn't resist. So for now, that's almost it. Just to summarise, adjust your luminance or exposure first and then balance your colours. After that, you may need to bounce to and fro between the two. Don't forget to use more than one instance of Lumetri Color if you need to, and don't forget the little trick of isolating what you think should be white with the crop effect. Finally, I really hope you see the value in using these scopes. Once you get used to them, not only will your footage look much better, but they will also help you to make them better much more quickly, rather than otherwise just adjusting colours without really knowing what's going on. So best of luck making your edits look much better.